Graphing systems of equations. A linear system is represented by two lines or equations, and these are straight lines. The point of intersection, which we've already sort of looked at in our previous lesson, is where the two lines, or it's a solution of the two lines. So the point of intersection, the POI, of the two lines is the solution of a linear system of equations. The point of intersection coordinates will make each equation true when the x, y values are substituted into each equation. And you can check to see if your solution is correct by substituting the solution back into the equations to see if the left side, and you might remember this when we looked at solving equations, the left side of the equation equals the right side. So there are several ways to find the solution to a linear system of equations. We're going to look at three in this course. Number one is by graphing, substitution, and elimination. We're going to start with graphing. So in order to be able to graph, we must first change our equations into slope and y-intercept form, or y equals mx plus b. I mean, you can use it in standard form and find your x and y intercepts, but it is truly much easier to sketch the graph when we know the slope and the y-intercept. So let's start by just reviewing what we know by changing these equations into slope y-intercept form. So we want to get our positive value of y all by itself. So right now it's already positive. So we're going to move our 3x to the other side and our negative 2 to the other side. And remember, when we do that, we can think about opposite operations. So we can subtract 3x from both sides and add 2 to both sides. Or you can use the concept of, if I move it across the equal sign, it changes signs. So I'm going to start by subtracting. So I'm going to have my 3x. To get rid of my 3x, I need to subtract it. So if I subtract it from the left-hand side, I also have to subtract to the right-hand side. So plus y minus 2. To get rid of the minus 2, I have to add 2. So again, whatever I do to the left-hand side, I have to do to the right-hand side. So I have 0, take away 3x, plus 2. So the x's are gone and the 2's are gone. So I'm left with y is equal to negative 3x plus 2. So that's one way to think about solving your equations, by doing it that way. For part B, I want a positive value of y. Right now it is negative on the left-hand side, so it's easier for me to go ahead and move the y to the other side. So in order to do that, I have to add y. So I have negative 2x minus y. To get rid of the y, I have to add it, plus 3. And again, whatever I do to the left-hand side, I have to do the right-hand side. So I'm adding my y. My y's disappear from the left-hand side. So I have negative 2x plus 3 is equal to y. So same format, but it's just backwards, and that's fine. So you can leave it like this, or you could rewrite it as y equals negative 2x plus 3. Okay, whatever works best for your understanding. Okay, and then the last one, again, I want a positive value for y. Right now it's negative, so I'm going to start by moving my negative 3 over, negative 3y over. So I have 6x minus 3y. To get rid of the minus 3y, I have to add 3y, and then plus 12 is equal to 0. So whatever I do to the left-hand side, I also have to do to the right-hand side. our 3y's are gone. They cancel each other out on the left-hand side. So I have 6x plus 12 is equal to 3y. But I want to get just y, so I have to divide each term by the coefficient in front of the y. So I'm going to divide each term by 3. 6 divided by 3 gives me 2, so 2x. 12 divided by 3 is 4, so plus 4. 3 divided by 3 is 1, so I'm just left with x or y. And again, you can keep it like this, or you can rewrite it as y equals 2x plus 4. Remember, if you have any questions about this lesson, please post them in the proper discussion board, and I will answer your questions as quickly as I can. So that's just the first preliminary thing that we wanted to look at, and this is a combination of our algebra skills, which we learned in 2 units before this, and our equations of lines in our last unit. So once we've identified how we can write our equations in slope y-intercept form, now we can start to look at solving our system of equations. So I'm going to take my equations for example 1, x plus y equals 6 and 2x minus y equals 0, and I'm going to rewrite these into slope-intercept form. So in this case, my y is already positive, so I'm going to keep it on this side, and I'm going to move my x to the other side. So right now it's positive x. To get rid of it, I have to subtract x. Plus y is equal to 6. And then I have to subtract x because whatever I do to one side, I do to the other. The x's cancel each other out, so I'm left with y is equal to 6 minus x. I can rewrite this so that my x's and my 6 are rearranged. So y is equal to negative x plus 6. So in this one, my slope is going to be negative 1 over 1, and my y-intercept is 6. All right, let's do it for the second equation. Right now my y is negative, so I'm going to move my y over to make it a positive value. So I have 2x minus y plus y is equal to 0 plus y. So my y's cancel each other out on the left-hand side. So I have 2x is equal to y. If I want to rewrite it so that it's y equals 2x, I can do that. My slope is 2 over 1. Remember, if it's not a fraction, I can make it a fraction by putting it over 1. And I have no y-intercept, for my y-intercept is 0. So now I can go ahead and graph these onto my coordinate plane. So I'm going to start with my first equation. So I'm going to label this equation 1, and this one's going to be equation 2. Again, you can use different colors if you're doing this at home using pencil crayons or different color pens, or you can just label your graphs, whichever is easier for you. So I'm going to start by plotting my y-intercept of 6, right up there. My slope is negative 1 over 1, so that tells me for every value I go down, I have to go over to the right one. I'm going to do that as many times as I can until I run out of room, because I don't know where my point of intersection is going to be. So I'm going to connect these points using a straight line. Ideally, you'd be using a ruler if you're at home, showing arrows to show that it goes in forever in both directions, and I'm going to label this as line 1. So the next graph I'm going to graph is the next one. So I have a y-intercept of 0, and my slope is 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. So this is my point where they cross, and I'm going to connect these with a straight line. At home, you're using a ruler. And this is my point of intersection. And the coordinates of this point of intersection is 2 and 4. So now I can check this. So I'm going to check it for my first equation and my second equation, just to verify that I've done this correctly. So For equation number 1, the left side is x plus y. The right side is 6. And I'm putting it back into my original equation. So the left side is 2 plus 4, which is 6. Look at that, they're the same. Left side equals right side. So that's beautiful, that's what we want to see. And then for my equation 2, the left side is equal to 2x minus y, and my right side is 0. So again, I'm plugging in my values for x and y. So 2 times 2 minus 4. 2 times 2 is 4. Take away 4 is 0. So left side equals right side, which is what I wanted. So therefore, I can say with confidence that my point of intersection is 2, 4. So that check is very important to make sure that you have your answer correct. So when you're doing this on an assignment or a quiz or a test, you can verify your own answer. So you can ensure that you're providing correct solutions. So now let's take a look at another example. Example 2. Equation 1 is already given to us in slope-intercept form, so that's beautiful, so we don't need to rearrange this equation at all. I can state my slope. My slope is 1 over 1, and my y-intercept is 3. For equation 2, I'm going to rearrange this. My y is already positive on the left-hand side, so I'm going to move my 3x over and my y over. So I have y is equal to negative 3x. I know I've skipped a step for you. So it's the opposite sign, so negative 3x, and then subtract 1. So moving that 1. So the opposite of positive 1 is negative 1. So if you are able to do it without showing all of your steps, you're more than likely to do it like I did here. Or if you wanted to show all your steps, you can do that as well. So this is my second equation. My slope is negative 3 over 1 because there's no denominator, and my y-intercept is negative 1. So now I'm going to go ahead and plot my lines. So plot my y-intercept first at 3 for my first equation. My slope is 1 over 1, so I'm going up 1 over 1, up 1 over 1, up 1 over 1. I don't know if my point of intersection is going to be up here or not, so I'm going to go in the opposite direction as well. So I'm going to extend that line because I don't quite know where my point of intersection is going to be. And then I'm going to connect these dots using a ruler, draw my arrows on either side to show that it goes forever, and label this as line 1. So now I'm going to graph my second equation. So I have a y-intercept at negative 1. My slope is negative 3 over 1, so it means I go down 3, 1, 2, 3, over 1. I can't go down any further, so now I'm going to go up. So 1, 2, 3 over 1. Look at that. There's my point of intersection right here. And then go up 3 over 1. So now I have a good number of points that I can just sketch. Again, you would be using a ruler at home, so your line would be much neater than mine. And I'm going to label this as line 2. So here's my point of intersection. And my point of intersection has a coordinate of negative 1 and positive 2. So I'm going to check to make sure that I've done this correctly by doing my left side, right side check. So for equation number 1, my left side is equal to y. My right side is equal to x plus 3. So left side is 2. Right side is negative 1 plus 3, which is 2. Look at that. Excellent. So far, I'm on the right track. So then I'm going to do it for equation 2 as well. Left side is equal to 3x plus y plus 1, and my right side is 0. So my left side is 3 times negative 1 plus 2 plus 1. 3 times negative 1 is negative 3. 2 plus 1 is 3, and negative 3 plus 3 is 0. Left side also equals the right side, so it works for both of my equations, which is what I wanted to know. So therefore, my point of intersection is -1, 2. Two more examples. Equation number 1. My y is already a positive value, so I'm going to move my -3x to the other side. So I have 2y is equal to, this becomes a positive, 3x plus 12. I want to get rid of the coefficient in front of the y, so I'm going to divide every term by 2. So 2 divided by 2 is 1, so I'm left with y. And then I can keep that as a fraction. Remember, it's easier to keep my slopes as fraction when I'm graphing. So 3 over 2x, and then 12 divided by 2 is 6. So this tells us that I have a slope of 3 over 2 and a y-intercept of 6. Equation number 2. My y is already positive on the left-hand side. I'm going to move over my -x. So I have 4y is equal to, the -x becomes a positive when I move it over, x plus 4. Again, I want to divide every term by the coefficient in front of my y, because I want just a y. So I have y is equal to x over 4, or I can write this as 1 over 4x. And then 4 divided by 4 is 1. So my slope is 1 over 4. My y-intercept is 1. So let's start by graphing these equations, plotting my y-intercept of 6. Now it says, my slope says that I have to go up 3 and over 2, but I don't have enough room to go up. So I'm going to go down. So down 3 over 2. Down 3 over 2. Remember, when you're going down, you're moving to the left, not to the right. There we go, down 3 over 2. All right, so I'm going to connect these using a straight line. Oh, that's terrible. Let's try that again. Again, at home, you're using a ruler, so your lines are going to be perfect. There we go. Draw arrows on either side to show that it goes forever in both directions, and I'm going to label it as line 1. Okay, equation 2. Plot my y-intercept of 1. My slope is 1 over 4. Up 1 over 4. Up 1. I ran out of room, so I'm going to go down. Down 1 and then over 4. Look at that. There's my point of intersection. Down 1. I ran out of room, so now I'm going to connect these points using a ruler so that it's nice and straight. Arrows on both sides to show that it goes forever, and labeling this as line 2. So here's my point of intersection. And my point of intersection has a coordinate of -4 and 0. So I'm going across to -4, but I'm not going up or down. So let's do that check to make sure I've done it correctly. Starting with equation 1, the left side is equal to 2y minus 3x. The right side is equal to 12. So 2 times 0 minus 3 times -4. 2 times 0 is 0. -3 times -4 is positive 12. And 0 plus positive 12 is 12. Left side equals right side. I'm off to a good start. Let's do it for equation 2. The left side is equal to -x plus 4y, and the right side is equal to 4. Left side is -x, or -4 plus 4 times 0. Negative times -4 is positive 4. 4 times 0 is 0. And 4 plus 0 is 4. So again, left side equals right side. So now I can say with certain, therefore the point of intersection is -4, 0. And last example, thank you for bearing with me. The more examples that we go over, the more examples you have to refer to, the easier it's going to be when you do these questions on your own. So my y is already positive on the left-hand side, so I'm going to move over my -4. Remember, when I move it over, it becomes the opposite sign. So I have y is equal to 4x, positive 4x, plus 6. So my slope is 4/1, and my y-intercept is 6. So this is equation 1. Equation 2, my y is negative on the left-hand side, so I'm going to move this one to the right-hand side. So, and because I'm doing that, can we do it in one step? Absolutely we can. We're going to take our 15 and we're going to move it over to the right-hand side. So here we go. X, so it's 15, so when I bring it over, it's going to be -15 is equal to this -3y becomes a positive 3y. Now I want to divide every term by the number, the coefficient in front of my y. So dividing each term by 3. So I have 1/3x. -3 divided by, or -15 divided by 3 is -5. And 3 divided by 3 is 1. So you can keep it like this, or you can write it as y equals 1/3x minus 5. So your slope is 1/3. Your y-intercept is -5. So you can keep it as x/3 if you want to. It's easier sometimes to identify your slope if you keep it as a fraction, so 1/3x. But I will accept both of these answers. So if you wanted to keep it of x/3 and you can easily identify that your slope is 1/3, go ahead and do that. If you want to bring it out in front of your x, you can do that as well. So let's plot or graph our lines, starting with our y-intercept of 6. Our slope is 4/1. I can't go up any further, so I'm going to go down 1, 2, 3, 4, and to the left 1. 1, 2, 3, 4, to the left 1. 1, 2, 3, 4, and to the left 1. So now I'm going to connect these using a ruler. It's a nice straight line. Arrows on either side to show it goes forever, and label it as line 1. And now same, we're going to graph line 2. Our y-intercept is -5. Our slope is 1/3. So I'm going up 1/3, up 1/3. Okay, so obviously our point of intersection is going to be in this quadrant, so let's go down. Down 1/3, look at that, there's our point of intersection. And now I can connect these using a ruler, nice straight line, arrows on both sides to show that it goes forever, and label this as line 2. So here's my point of intersection. It has a coordinate of over -3 and down to -6. So let's just check to make sure this is correct. We're plugging it into our original equations. Start with equation 1. The left side is -4x plus y. The right side is 6. -4 times -3 plus -6. -4 times -3 is 12 minus 6, because these cancel each other out. So, well, don't cancel each other out, but the positive and the negative gets a negative, and then 12 take away 6 is 6. So that's good. So left side equals right side. And we're going to do it for equation 2. The left side is equal to x minus 3y. The right side is 15. So x is -3. So x is -3 times, or subtract 3 times -6. So I have -3. -3 times -6 is positive 18. And -3 plus 18 is 15. So that's the same. Left side equals right side. So now I can say with certain, therefore, my point of intersection is -3, -6. And that's how we find our point of intersection by graphing.